Hi grade 10, so today we are going to be looking at speed and velocity. So we're moving on from distance and displacement, but because physics right now is such a building unit, we are going to definitely be using distance, displacement, and having to understand what scalar and vector are. So if you ever need, go take a look back in your notes, make sure you understand those different terms, because like I say, it's really going to build, especially starting today when we look at speed. So there's a lot of notes to cover today. I'm going to give you kind of a brief summary of what I think are the most important parts. Please make sure that you read through the notes, make sure you understand everything. If you have any questions, let me know. So speed, the speed of an object is how fast the object is traveling. So it's a scalar value, meaning that we're not concerned about direction. So to help further clarify, speed can be thought of as the rate at which an object covers a distance. So you can see that we use the word distance there, meaning that when we're calculating speed, we're using distance. So speed and distance are both scalar, and then speed is the rate at which an object covers a distance, or how fast the object is traveling. So look at instantaneous and average speed on your own, and we're going to jump right into calculating average speed. So if you want to calculate the average speed of something, we have a handy-dandy little formula here. So our average speed is equal to the distance traveled divided by the time traveled, okay? So we're looking at our distance divided by time. So our formula looks like this: V is equal to D divided by T. So you're wondering about the V in the equation? V is actually the symbol for speed. So in the equation above, V is equal to average speed, right here. D is equal to distance, right here. And T is equal to time. So you have to remember that when we're calculating average speed, it is equal to the distance traveled divided by the time traveled. So we already know how to calculate distance. We're always given a time as long as we're solving for speed. So this is how we can now do a couple examples so we can see how to calculate average speed. So it says an individual traveled 440 kilometers in 8 hours. What was their average speed? Step 1 is write out the equation you need. So always make sure that you're writing out the equations when we're doing our different calculations. It'll be worth marks, and it's really important so that you don't get confused about what you should be working with. So as soon as you see that you're calculating average speed, you write down, okay, I need V equals D divided by T as my equation. Step 2 is fill in the information that you have. So if we look at our question here, an individual traveled 40 kilometers. Okay, so we know 440 kilometers, is a distance. So that's obviously our distance traveled. So we put that into where the D was in our equation here. And then it took us 8 hours. So we know our time is 8 hours. So we have a V is equal to 440 kilometers divided by 8 hours. Step 3 is to calculate out to get the answer, and make sure you include units. So if you do 440 kilometers divided by 8 hours, you get 55 kilometers per hour. So we know our speed is equal to 55 kilometers per hour. Let's look at another one, just shortened up here. So you don't always need to write out step 1, step 2, step 3, but you should write things out like this so that you can get full marks. And so it helps clarify, keep your understanding of what you're doing in that equation. So it says a smelly cat should say a smelly cat ran 13 meters in 6 seconds. What was smelly cat's average speed? So we know we're calculating average speed. So we write down our equation, V equals D divided by T. Fill in our information. So 13 meters was our distance, 6 seconds was our time. 13 divided by 6 equals 2.17 meters per second. Okay? So we can always, sometimes you're not given the exact information that you need to calculate average speed, but you might be asked to calculate distance or time. So what you need to do is rearrange the formula to isolate the variables. So we'll take a look at how to rearrange this formula in one way, and then you can always rearrange it into whatever format you need. So a car was traveling at 100 kilometers per hour for 5 hours. What was the person's distance? So in this case, we're looking to solve for D rather than solving for V. So we already have the speed, which is 100 kilometers per hour. And so now we're looking to try and solve for distance. So our first step is to write out our formula. So we know our formula is v equals d over t. And now we need to rearrange to isolate for the variable that we're trying to solve for. So we said we want to solve for d. We need to rearrange this formula so that we have d on one side of the equation by itself. So here are the steps for rearranging the formula. Some people find it easier to fill in the information and solve for this equation. So you would put 100 kilometers per hour equals d divided by 5 hours. You could fill the numbers in and then solve if that's easier for you. But if it's easier to rearrange the formula, here is very detailed steps as to what you're doing. So we're trying to calculate distance, so we need to get d by itself. To rearrange the formula, you must take the opposite sign of the value you are moving and do it to both sides of the equation. So here are the signs and their opposites. So the opposite of subtract is add, and the opposite of multiply is divide. So in this case, we want d by itself, so we have to move this t value. So in this equation right here, right now we're dividing by t. So if we take the opposite of that sign, we multiply by t. So we multiply by t on either side of the equation. When we multiply on either side, the t's cancel out, as we can see here. And then our equation is left as v times t is equal to d. So after you've rearranged your equation to be what you need it to be, and have this variable that we want to solve for isolated by itself, then you can fill in your numbers. So we have 100 kilometers per hour times 5 hours is equal to distance. Because of these fractions, so we have 100 kilometers per hour, this would be 5 hours, and that would be over 1. The hours cancel out, so we are left with distance is equal to 500 kilometers. Okay, so again, remember that hours cancel out, leaving you with only kilometers. So this is a bit math heavy. So if you need help remembering how to rearrange formulas, take a look through here. And if you have any other questions, please reach out to me and let me know. So again, this fraction would be 5 over 1. So you would have 100 kilometers times 5 hours over 1 hour times 1. And these two would cancel out when we're doing our fraction multiplication. Okay, so after all of this, we've rearranged all of this, filled in our numbers, our distance here would be 500 kilometers. So the same equation can be rearranged again if you are solving for t. I'm not going to write all those steps out for you because it takes so much space, and I'm sure that you guys can figure that one out. The 3 equations that can be used if you want are written out here. So to calculate for speed, v equals d over t. To calculate for distance, d is equal to v times t. And to calculate for time, it is t is equal to d divided by v. Okay, so if you have any questions about rearranging formulas, if you have any questions about how to do these calculations, let me know. Again, make sure you're reading through this top part by yourself, making sure that you understand all of these steps. I've just kind of broken things down briefly here for you. Again, this is a very quick video, so if there's any questions about any of this, please let me know. So here are your practice questions. There's 4 practice questions for you to do. If you have any questions with those, again, reach out, send me a message on Edmodo, whatever you need, and we'll get it all sorted out.